Hi everyone, today's proof is about perpendicular bisector. Um, it is a very common construction when you need to construct a perpendicular bisector of segment AB. You construct two circles or just arcs with the same radius, that's important, with center at point A and center at point B. Okay, then when they intersect at points P and point R, you are going to draw a line, and that line is supposedly perpendicular bisector of segment AB. But the question is why? Why is that line a perpendicular bisector? So I have a diagram here where I took a random radius, so it works for any radius, which means that I'm basically proving the next statement for for all the points on the line, on the yellow line PR. So what I did is I constructed my perpendicular bisector. Well, supposedly I don't know what it is, and now I'm going to just to do a helpful construction. I'm going to connect points A and P, and that is not what I wanted. I wanted a line AP. Okay, much better. And then I'm going to connect my point P and point B. And I'm also going to connect point A and point R and connect point R and point B as well. So now when all those points are connected, I would like to label everything that I know, which is all the information I know, which is AP and PB, those are radii, same radius. Remember, both of those circles had the same radius, so they have to be equal. And also AR and RB, they are also radii, so those should be equal as well. So now how do I start a proof? On the left side, I'm going to do two-column proof. So on the left side, I'm going to write down statements. And then on the right side, I will write down justifications. Justifications. Two-column proof is it's very common in high school geometry. That's how we often do it in high school. You can also do a paragraph proof. That's what I used to do when I was at school. I honestly like it a little bit more, but I know this is what's required these days. They're very similar, however. So my statement number one, oh, I think I'm still on the, okay, statement number one is I have, that's what I just labeled, that AP equals PB equals AR, and it is equal RB, right? And justification is why that is so. Well, why is that so? Because I use two circles with the same radius, right? So I can say radii are equal for two circles. So I kind of know what I mean by that. So radii of these two circles are equal, or radii are equal. AP and AR are radii of one circle, PB and RB are radii of the other circle, and AP and PB are equal because the two circles, they have the same radius. All right, now my second step is kind of logical conclusion from this. Now I'm looking at my diagram. I'm looking at the quadrilateral, the green quadrilateral here, APBR, and I see that it is a rhombus, right? So I'm going to say that APBR is a rhombus. And why is that? That is a definition of a rhombus. A rhombus is defined definition of a rhombus. A rhombus is defined as a quadrilateral with all four equal sides. So that's a definition of a rhombus. All right, perfect. Now, what I can do is, if I know quadrilaterals already, then I can just say that, oh yeah, it's a rhombus. I know that in a rhombus the diagonals bisect each other, and then I'm done. The thing is, usually we prove the perpendicular bisector statement, theorem, before we learn about quadrilaterals, right? So what we will do is we are going to prove something about triangles in this rhombus. And I'm going to, for that purpose, I'm going to label this point point O. I'm going to call it point O, or whatever, any other point. I like O. And now I can see that my triangle, well, I can probably start. Okay, I'm gonna go back one step. So I'm looking at triangle APB, so this triangle right on top, and then I'm looking at triangle ARB over here, and I noticed that those triangles, they have to be congruent, but in order to prove that, I'm going to be using side congruence. In order to prove that, I have to say that AB is congruent to itself, because I have two parts already, two corresponding parts, but I wrote them down here, but I need to say that AB is congruent to AB or equal AB. If I would put a segment here, I would say congruent, so AB equals AB, and that is reflexive property. Reflexive property says that a thing, a shape, a figure is congruent to itself, right? So this pen is congruent to itself. Yeah, these headsets are congruent to themselves. That's a reflexive property. So AB is congruent, or AB is equal to AB. And also, since I'm using the same justification, I'm going to say that PR is equal to PR. It is the same justification, so I have kind of like two different steps in one, two in one. Now for my step 4, now I'm ready to say that triangle APB is congruent to triangle BRA. Okay. And then why is that? That is because of side triangle congruence theorem. Okay. Similarly, I'm going to put, since I'm using side, I'm going to say that, what am I going to say? That my triangle APR, so this triangle to the left up, and this triangle to the bottom right, they're also congruent. So triangle APR is congruent to triangle BRP, burp. Okay, same reason here. Now remember that we have to label the triangles in the correct order. So if I'm starting here, APB, right, I cannot say that it's congruent to triangle RBA, because R does not correspond with A. We have to have corresponding pieces. Now, since those triangles are congruent, we know that the corresponding parts of congruent triangles are going to be congruent as well, which means that this angle over here has to be congruent to this angle over here, right? This angle is also congruent to this angle over here. And by the way, those two angles are congruent to each other because they are the angles in an isosceles triangle. Triangle ARB is an isosceles triangle, so those two angles are congruent to each other. So with the proof, I have to write that all down, and I'm going to write them in step 5. So in step 5, I can say that triangle APB, triangle PR, triangle ABR, and triangle PBR are isosceles triangles. And the justification for that is why they're isosceles, because of the definition of isosceles triangle, right? Because the two sides are congruent. Definition of isosceles triangle. All right, now on to step number 6. In step number 6, that's what I just said, that corresponding parts of congruent triangles are congruent. So I can say, I'm going to say it like this. Angle, I'm going to label them angle 1, 2, just for simplicity, so I don't have to use 3 letters for each angle. So I'm just going to say angle 1 is congruent to angle 2, is congruent to angle 3, and it is also congruent to angle 4. And the reason for this justification is that we have angles in isosceles triangles, right? And we have same side, not same side, sorry, CPC F, which is also known as CPCT or CPCTC, depending on the textbook, depending on the teacher, depending on school district, they're called differently. I like this one because it's the most general theorem. It says that corresponding parts of congruent figures are congruent, right? So it's congruent figures. It doesn't have to be just the triangles. So CPCF, and then angles, base angles in isosceles triangles. Okay, there is a theorem that is telling us that the base angles and isosceles triangles are congruent. If you don't remember the proper name of the theorem, then you have to list kind of like what it says, kind of like what I did here. All right, so now we have those angles are congruent, and then very similarly, I'm going to use a different color here. Okay, let me see, a blue color. So similarly, I will have angles over here. I'm going to use two little tick marks here, or two arcs here, to show that my angles, let me label them angle 5, 6, 7, 8, are congruent. Okay, so I can put it also in here. Angle, I don't know why I started it with 7, 7, 8. It is also congruent to angle 6, and it is also congruent to angle 5. So same reason as we had for from steps 5 and 6. Yeah, so we have two isosceles triangles, and you had two isosceles triangles and two congruent triangles. All right, now let's take a look at just this small triangle ARO, right? You have a green angle and the blue angle, and then this side, and then your triangle APO, you also have a green angle, a blue angle, and the side. So you have side, angle, side, right? Side, angle, side. I'm going to continue the proof so that I don't have to scroll down and go away from the picture. I'm going to continue it right here. So my step number 7, step 7, is going to be the triangle APO is congruent to triangle ARO, right? And they're also congruent to those two triangles. And also congruent to triangle, we have to label them in the right order. So that's going to be our triangle BRO. And also congruent to triangle BPO. And why is that so? Our justifications. Okay, I'm sorry. I need to do a line here. I cannot see this. Okay, it's much better. All right, back to the pen. So the justification is because of angle, side, angle, triangle congruence. Okay, now since those triangles are congruent, that also means that this side, right, has to be equal this side, because they're corresponding sides. So my step number 8, I'm going to say that AO equals BO because of CPCF, the corresponding parts in congruent triangles, these two congruent triangles and these two congruent, or I guess these two congruent triangles, right? This side and this side. And another thing that I notice is that this angle over here, it has to be congruent to this angle over here, right? So my angle AOP has to be congruent to angle BOP. That is also because of CPCF, but also we know that AOB, that is, AB was a segment, so angle AOB, measure of angle AOB, has to be equal 180 degrees, right? Because AB is a segment. AB is a segment. That is step number 10. Step number 10. So finally, I can say that that means that those two angles are equal and they add up to 180 degrees. What does that mean? Well, that means that measure of angle AOP has to be equal 90 degrees and angle BOP as well. So that is just algebra. Okay, and then finally, what did we have? We have that PR, that segment, that line PR crosses our segment AB in the middle, midpoint. O is the midpoint, right? And it's perpendicular. So what does that mean? That means that line PR, line PR is a perpendicular bisector of, I need to leave a space here. I was trying to fit it all in here, of our segment AB. Why is that? That is the definition of perpendicular bisector. Definition of perpendicular bisector. I'm using the notation for perpendicular here. Yeah, perpendicular, like this. Don't look at that line. So for the proofs, it's important to remember that you have to show step by step everything, step by step your logic process. You have to prove that triangles are congruent before you can use CPCF. So if you see something, some sides are equal or angles are equal, just think, oh, why are they equal? They look like they're equal. Oh, because the triangles are congruent. So let me use CPCF. Now, when you look back, you actually can even notice that maybe some steps were not necessary. I'm looking at step number 2 here, so that step maybe was not even necessary unless I was using the proof that I mentioned before, right? So that it's a rhombus, so diagonals of rhombus bisect each other. But again, to prove that diagonals of rhombus bisect each other, we actually use this proof, the perpendicular bisector proof. So I could have went from step 1 immediately to step 3. I'm pretty sure there might have been some other steps that could have been kind of like put together a little bit neatly, but it is okay to just write down what you notice and label the correct parts. It is helpful if you color code, but at least be very, very neat about your diagrams. Name them, name the triangles and the angles in the proper order, and remember your definitions, theorems, postulates, all that stuff. If you don't remember, then you kind of write down what it says. So base angles and isosceles triangles are congruent, right? So you can do it that way, and then that is your proof. You could have also done this in a paragraph form, so you would kind of like write it down pretty much what it says. You would say that those segments are congruent because the radii of two congruent circles, which means that the triangles are congruent, and also AB and PR, they're congruent to themselves. But you also have to mention the justifications, so you do have to mention those, kind of like do those steps, but you just write it down more like an essay. So for some people, it's much, much easier. Okay, well, I hope that was helpful. If not, then rewatch the video, shoot me a question, and I will help you with that or record more videos if you need me to. All right, have a nice one. Bye.